range. Just out of curiosity. Just the range, okay? Oh, that's such a bad picture. Harper, don't be hating on my picture. Okay. I know. That's such a messed up picture. But it'll do. Of course, we're just talking about range. Then I want a star-worthy problem, okay? And I want you to find the domain and the range for this one. This isn't easy when you don't use a grid. But you don't have grids on your paper, so. I want you to find the domain and range. I also want you to name the x and y intercepts. Of course, where I make those big old dots, they are crossing clearly on a line. Clearly, okay? Use your imagination. Draw your picture better than mine. Pardon me? This one? This one? This one? What? This one? Yeah. Clearly. Clearly it is. Absolutely. Yes. It's very clear to me. Isn't it clear to y'all? The pictures are awesome. So we're only finding, only finding the range for examples 1, 2, and 3, okay? Now, just the range. Range has to do with what values, x's or y's? Y values. So my y values are going to run from what to what? All right, negative infinity to positive infinity. Do you guys agree with that? Okay. And here's my thing. Once you write the interval notation, now let's write the compound inequality, which is going to be negative infinity. What kind of symbol? Less than, because this is your smallest value. It's less than what value? Y, which is also less than positive infinity. Okay? You got to get accustomed. And I just saw something on someone's paper that I should have started. I'll show you in just a second. But how many of you had negative infinity to positive infinity for the range of number 1, linear function? Good. Okay? Look at number 2. Just again, dealing with the range. This is the way I should have told you. And you know, hindsight's always 20/20. What's the vertex of this parabola? -2, -1, right? Okay. For me, for hope, I've got to do this for the range. Because if I don't, I'm going to make a careless mistake. And careless mistakes make me crazy. But I know that my y values are going to be greater or less than -1. If it's a min, then they're all going to be greater than that value. Do you guys agree with that? Okay, so y is greater than or equal to -1. Do you have that on your paper? I hope so. Now I would write, from that, I would write my interval notation, okay? Remember, we want to go little to big when we're working on interval notation. So what's my smallest value? -1. That's my smallest value. What's that going to give me? And look, y'all, it's right here, but we're going to flip it around. It's going to be less than or equal to y. Do you see how that I just literally flipped it around? And then what's y going to be less than? What's it going towards? What kind of infinity? Positive infinity. I did that totally. Flipped it, didn't I? Because I said I was going to do interval notation and then the compound inequality. Is that what I said? I was going to do interval notation and then the compound inequality. Right, okay. So do this for me. On your smart board at your desk, in there, okay, and you can erase it if you want to, but I should have done, what's going to be my value? What's my smallest value? -1. Is that going to warrant a bracket or a parentheses? Bracket. And it's running where? To positive infinity, which warrants a parentheses, right? If you were to do the y value first and then interval notation, this shows you the order in which you have to write your compound inequality. The -1 with the bracket means it has to have a line under it. Y has to go in the middle. And then positive infinity with a parentheses, which means without the line under it. It would mean the same thing, but try to force yourself. If it were an accident, then it's an accident. I would try your best to force yourself into going smallest value to largest value. It just makes sense. Just makes sense. Okay? Questions on that? How many of you had number 2's range correct? Rock on, y'all. Very good. All right, real quickly, what's the range for example 3? Move that up so you can see it better. What's the vertex? What's that ordered pair? 2, 4? You guys agree with that? For me, I got to do this. My y values are what? Talk to me. Less than or equal to 4? How many of you had that? Yeah? Interval notation. So all my y values are below that vertex, correct? So if I were writing interval notation, what's my smallest value going to be? -infinity, ding, 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 parentheses, right? And it's going to run from -infinity all the way up to +4, which gets a bracket. And now I can write my compound inequality, can I? So it's going to run -infinity less than what? Y, then what? Less than or equal to 4. How many of you had that one correct? That's what I'm talking about. Okay? All right, look. You know, I can never physically put my hands on infinity, right? Because once I think I'm there, it'll just step away from me. And once I think I'm there, it's going to step away from me again, right? So I can never touch it. That value could never be included because there is no value to include. It's one of those, like, deep thinking problems. You can't get to infinity. Y'all get that, right? Yeah? You get that? It is still a value. Yeah, that's what's so weird. It's still a value, but I can't put my hands on it. You know what I'm saying? It's weird. It's just one of those weird. I mean, who says when we draw a point, this is the whole thing in geometry. When you draw a line, are there any true, and you guys who've had me in geometry class, you've already heard this, but are there any true lines on this physical earth that we live on? Why? Because lines don't stop, right? We know how to symbolize a line. What makes a line different than a segment? The arrows, right? We know how to show a line, but there's no line on this earth that we can really put our hands on. We can put our hands on segments, right? Isn't this a segment right here? The edge of my podium, that's a segment. But it's just that math is kind of weird sometimes. Questions, other questions, yes? Never. Kinda. Yeah. It's deep thinking, that's right. Right on. Okay. You went there. Questions, other questions? What about example 4? How many of you are happy about 4? Happy about 4. All right, here we go. Let's go with the easy stuff. X-intercepts. What are the x-intercepts, folks? Go from the left to the right. -3, -1, 1, 4. Holy moly. 4. Y-intercepts. What is that y-intercept? 1, isn't it? Right up here. Just 1. Is that okay? Sure. That's what the graph's showing me. Domain and range. Let's look at the width of that curve. What's that curve? What's the domain? What are all the x values going to be for that weird looking curve? Who? Negative infinity to positive infinity, or all real numbers. You could also put the all real symbol, that double R thing. How about the range? -2 to positive infinity. What made you choose -2?
Because if you're starting at -2 and going up, you're going to reach that other point in the parabola anyway.
What's this kind of look like, smashed together? This kind of it does look like a W. I agree with you 100%. It looks like a W, right? A mathematical W. Doesn't it look like 2 parabolas that have kind of gotten joined? It's like conjoined parabolas. They're joined at the, I wasn't going to say that, but okay. But this kind of like conjoined parabolas, isn't it? So we follow the same rules. We find the bottommost vortex, and then we get blue elephants and pink pigs, and we see what they can form together and see if they can fly in the air. What? This is the look I'm getting right now. I know, because this is what some people are still doing. They never heard pink elephants, blue elephants, whatever I just said, with clouds and stars and whatever. I don't know what I said. Okay. This is exciting stuff, y'all. I don't understand why you're not excited about this. We follow the same rules as we do for parabolas, finding the range. Find that bottommost point. The bottommost point appears to be what in this graph? 2, -2. And again, I'm dealing with 2, -2. That's a +2 and then a -2. And I've got to circle my y value, because if I don't, I'm going to make a careless mistake. So the y's look like they're going to run from y where? Your y values are what? Greater than or equal to -2. And then if I were to put that in interval notation, what would go first? Think on this. -2 is my bottommost point, right? Is it going to have parentheses or brackets? Brackets, -2 to what, folks? Positive infinity, which gets a parentheses. And now if you were to write that as a compound inequality, it's right there for us. -2, y, positive infinity. What kind of sign goes in between the -2 and the y? Less than or equal to. And what kind of sign in between y and infinity? Less than. How about them apples? How many of you got that one right? Excellent, folks. Very good. Questions at all? You got this stuff.
On the graph, how did it like
Okay. We're going to do that tomorrow. If this is like two conjoined parabolas, an x squared and an x squared, just throwing it out there, what do you think maybe the highest degree of this equation would be? It would be a 4, okay? This is a polynomial equation of degree 4. So if you have a curve, this is a preview to tomorrow. If you have a graph that looks like this, what do you think that might be? Take a stab at it. Do you think it's going to be a polynomial function, but it's going to be of degree what? Do you think? What'd you say? Why 3? Here's something else you can look at. 1, 2, 3. I'm not really necessarily counting the x-intercepts, but I am counting the movements and the changes of that curve, okay? What if, because you could have, do you know what that's called? It's called a cubic polynomial equation. I can tell that you are thrilled to death to know this. When you are on Jeopardy, you will be able to answer this question. Now you can buy groceries, folks. I know. You can feed your family. This is called a cubic. We're going to go over this tomorrow, okay? Now, what you're going to do for me, so I make sure that you know what you're doing, you're going to get your workbook out. You'll have a little something, something. This is going to be turned in for grade, folks. Because if you can grasp the concept of domain and range with parabolas, and we've already looked at a degree 4 equation, and you get it, then everything else is gravy. All right? This is what you're going to do. We looked at page 63. I want you to look at page 64 in your workbook. And you are going to complete 7 through 12. Now, look what you have to do. Got to do a couple different things. You got to sketch the graph. And a sketch is a sketch, folks, okay? Sketch it. Then you're going to find your x-intercepts, your y-intercepts, if they're there, and you're going to find your domain, and you're going to find your range. Bless you. Okay? Is what? I would list all 3 ways for your range. It's just setting up good habits for you to know what you're going to see when it comes SOL time. Okay? And folks, we are like 5 weeks out. 4 weeks out from the SOL. Yep.
How much we got left?
I don't know. No. Don't worry about it. Yeah, but I'm going to tell you right now, you got to keep in mind, you're getting into advanced math. There will be no more 2 and 3 weeks of review before the SOL like you have had in Algebra 1 or Geometry. No more of that. We'll go right up until about a week out from the test, and then we will bust it. Test, review, test, review, test, review. Okay? And you probably will be getting some work packets that I'll give you, like your Bell work or your hot notebook. I'll give you an old SOL test or a coach book test on Monday, and it'll be due the following Monday. You got plenty of time to work on it, okay? You got to do something outside of this class, though. Does everybody understand what you're going to do? Be sure you label everything. Do not make me guess whether it's the domain or range. You better at least put D and R so I know. Questions at all?